Hello everyone, welcome back to Adrian's Digital Basement 2. On today's video, we're going to be taking a look at this. It's a BlueSCSI version 2. This is a new SCSI emulator. Well, new as in the new version. This uses a Raspberry Pi Pico, which is an RP2040 microcontroller, to emulate SCSI devices. And you can use it with all sorts of different SCSI devices. This one was sent into the basement by Joe of Joe's Computer Museum. Thank you very much, Joe, for sending this in. I recently used this on a project on the main channel. I'm not sure if it's going to be out, that video that is, before you see this video. But in this video, I want to test something that I think a lot of people aren't aware of that this particular device can do. And it's called SCSI Initiator Mode. The whole point of that mode is instead of emulating a SCSI hard drive or a CD-ROM drive or something like that for a computer, SCSI Initiator Mode changes this into a mode where this acts as if it's a computer itself, and then you plug in a SCSI hard drive to this, and what it does is it automatically starts to dump the contents of your SCSI hard drive onto the SD card. So if you have a real hard drive that is still working, you can very quickly image it onto the SD card, and then you can take the hard drive out of use, so it won't break or whatever on you, and then you can just install this into the computer and essentially just use the computer as if it had the original hard drive in it, but now you have a solid state emulation. And of course, you could take the SD card out, stick it in your computer, make a backup of that image, you can change it on an emulator. It's really awesome that something like this exists. What's really cool about this particular mode is if this hard drive were just IDE, it'd be easy to buy one of those USB to IDE adapters that plugs into the connector here, and you could plug that into a modern computer, Linux, Mac, Windows, whatever, and image the hard drive into a file and do all that work. But connecting SCSI hard drives up to modern computers is a lot more difficult. In fact, I have an old ThinkPad computer that was sent in by a viewer. It runs Windows XP, it runs Linux, and it has a PCM CIA SCSI controller in it that I use specifically for that purpose, imaging SCSI hard drives, and then also reading the contents of SCSI hard drives. And again, that's because with modern computers, it is so difficult to read SCSI devices. So that's where I think that this BlueSCSI can come in super handy with this initiator mode. And in this video, I want to test out a few different hard drives. I have a little pile of different drives here. They're all SCSI drives. And I also want to check to see if it works with removable devices. This is a SCSI zip drive right here, so we can see if we can dump the contents of a zip disk. And I also have a 135 megabyte SideQuest Easy drive. Let's see if we can dump the contents of this. As a side note, the SideQuest Easy drive, I've had several of these on the channel and they've all been broken, but I think this drive and this disk actually work. So we'll find out if they do. To use the SCSI Initiator Mode with the BlueSCSI, you're going to need a couple things. You're going to need a power supply to power up your hard drive or whatever the attached peripheral is. You'll probably need a 50-pin SCSI ribbon cable, and that's for plugging into things like these hard drives. And then for things like the zip drive, which this is an external one, so it has a 25-pin connector on it. I took this out of an old hard drive enclosure a long time ago. It has a 50-pin SCSI connector to the Centronics 50-pin style right there. And combining this with a cable like that goes from the Centronics here to the 25-pin, I can plug that into the back of my zip drive. Now, where could you buy these types of cables? I'm not sure, but again, if you're trying to make something like this, look online for potentially a broken external SCSI enclosure that you see has these types of connectors on it. Then inside should have a cable like this, and then these types of SCSI cables from the 50-pin to the 25-pin are relatively ubiquitous. This is the SD card that I was already using with the BlueSCSI, and it looks like it has a log file on here, which I actually never really looked at. Actually kind of cool. It just sort of talks about how it was configured. Now, while I was using this on the particular project I was working on, I had two hard drives configured, HD0, so ID0, and HD ID1. It shows it configuring that stuff, and yeah, it all pretty much worked. I'm just going to move these hard drive images into a directory here, and we're going to edit the BlueSCSI INI file because this is how we switch this thing into initiator mode. Taking a look at the documentation for the BlueSCSI version 2, talks about what initiator mode is. It says that to use initiator mode, you need the desktop version right here. The earlier versions of this particular device used a blue pill. I think it's a blue pill. I'm not 100% sure that this firmware and initiator mode is compatible with that. I'm assuming that is a no, because the two versions that it says it needs are 2023-09A and 2023-10. Anyhow, all we have to do is change this to Initiator Mode 1. So we'll copy that, add that into the file, hit save, Looks like we need to move a jumper labeled initiator and target to the initiator side, which on this particular hardware, there's an initiator jumper right here. So we change this over. And then there's an initiator jumper here. And it does say we have to install a jumper on there. Oops, my phone just buzzed. We need to install a jumper on that particular spot as well. There we go, jumper installed. And then next is talking about termination consideration. So both ends of a SCSI bus need to be terminated. So the controller, which is going to be this, and the drive that you're connecting as well. Well, the last drive, if you have multiple drives, and all the ones in the middle shouldn't be terminated. Only the one at the end of the chain, and of course the other end of the chain, which is a controller, should be terminated. It says here, some target devices can terminate the bus, but require termination power to do so. BlueSCSI can send the power to the termination and power line with the backfeed jumper set when powered via the floppy power connector or USB Type-C. So that's a new hardware revision, which it looks like this one is not, because this one has a micro USB. Now looking at this BlueSCSI here, we have a floppy drive connector here, so this I guess can backfeed the termination power, provides enough, and the backfeed jumper is right here, back. Now it's my understanding that most computers out there do feed termination power onto the SCSI bus, but not all, some don't, like the Macintosh Plus. I think all of these devices that I have sitting here will work on a Mac Plus, which means they probably work fine without termination power. So we'll try it first without, because what I'm not totally clear on, the documentation isn't exactly explicit, is if I power this using the power connector here, is it okay for me to also hook up USB power to the Pi Pico? The reason why I want to hook up the Pi Pico to power is it's not really to power, but it's to the computer. Because while this is in initiator mode, or maybe actually all the time, but at least in initiator mode, if you plug the Pi Pico into your computer, it actually shows up as a USB serial port, and it allows you to monitor the progress of the entire, well, dumping process of the hard drives you have connected. I suppose the Pi Pico is actually always in serial port mode, which means even while this is in normal SCSI emulation mode, you can see real-time progress as well. But in that case, I just don't know if the Pi Pico here powers the entire board, and I'm also hooking up an external power supply, which you don't really want to connect two 5-volt rails together like that, like from my bench lab computer up there and the one that's powering the hard drive. I suppose what we can do is I'm going to plug my little power supply into the wall here. Let's plug this thing in and see if the Pi Pico is powered up. Okay, so the Pi Pico is definitely powered up when I plug this in because it has an LED that's blinking on there. And now if I power this thing with the micro USB, see, it also powers this board as well. So it implies that the power rails are all connected together. That means, yeah, if I connect this power supply up while the USB is connected, then the bench or lab computer's power that's going to the Pi Pico, I don't know. That makes me a little bit wary. I'm gonna have to do a little bit of investigation just to try to figure out if this is safe to plug both of them in. If it's got like two diodes, for instance, then it's okay because you can't backfeed one into the other. But it's not totally apparent to me if that is how this thing is configured, and well, I don't know, I'm just not totally sure. Okay, a little bit of investigation. Yep, there's an extra jumper on here, the power on jumper, and it was installed on this particular unit. And it looks like if you remove that jumper, it isolates the Berg power connector, which is the floppy connector from the SCSI and the SCSI bus from the Pi Pico and the rest of the electronics. So that is the one we want to use. That will send the floppy drive connector power to the SCSI bus to run any termination resistors that exist on the external drives, and then the Pi Pico itself won't be powered off the floppy connector. It would require to be connected to a USB connector. One more thing I had to do with this thing is update the firmware to the latest version that you see here, which is this 2023 11.16, and that allows the initiator mode to work on this device. All right, so we have our INI file, which I have already saved. Let's pop this SD card into here. And what I'm gonna do is, without having anything connected to this, I'm just gonna plug the USB cable in. And taking a look in Device Manager, I do see COM13. I'm just gonna unplug this, make sure that that goes away. Nope, that did not go away. Oh yeah, I remember now that this COM13 is actually going to my scan converter. I have a USB adapter connected up here, and that's so I can send commands directly to the scan converter for doing capture stuff. So that means that this thing is unfortunately not showing up as a serial device, which I was under the assumption that it would. Back in the documentation, it does say that the LED on the BlueSCSI will flash to indicate that it's scanning for targets, and I didn't see any flashing. So I'm wondering if I did something wrong with this config file. All right, so taking a look at the log file that's on the BlueSCSI, it does say it was in initiator mode, will scan bus for drives to image, and that's all it really says. So I wonder why we didn't see the flashing, and I wonder why we also don't have access to it via a serial port. Now, incidentally, it is actually flashing right now, but that's normal, and that's when you have an SD card that you pull out. It has hot swap support. So if you are emulating hard drives with this, you can actually pull this out while the system is running. Obviously, you can't access the data that's on the SD card because it's removed, but this will continue to emulate hard drives and respond to the host. And when you connect this back in, it will reconfigure the SCSI devices based on any changes you've made to this. Or if you've just altered the contents of one of the files, then the contents is now altered on the emulated hard drive. So that's pretty handy. If you have one of these and say you run your SD card to an external slot on your computer, then you can make changes to this without having to reboot your systems. Very, very handy. Okay, well, let's just plug this into something so we can actually test this imaging. This says Amiga/George on it, so I guess it's an Amiga hard drive. Don't know the details on it. Let's just plug it in. We have to make sure it's terminated. It does have termination resistors. They are physical on this drive. They are installed right here and here. If they're removed, you're going to need to figure out a way to terminate the end of the cable. So, for instance, if you have a cable like this one, see it has two jacks on one end. Well, I can install this side into the hard drive and then say plug another hard drive in that has termination resistors, or there are ribbon cable terminators, although those are kind of rare and hard to find. So I recommend you just plug in a second drive that is terminated. In this case, though, this should actually work. So I have the power unplugged from that. Let's plug in this hard drive here. And the little splitter cable is very handy here because I can then just plug the Berg connector in so we can get the termination power to the drive. And if we plug in the power supply here, it should spin up the drive. And now it's not powering the Raspberry Pi, and that's understood. That's because, of course, that jumper's been removed. Okay, so the drive is spinning, and we'll plug in this USB cable, which will initialize the Pi Pico, and should start scanning and dumping the hard drive. It's not doing anything. Now, right now, this would be very handy if we had access to that virtual serial port, because we can see what's happening. Because right now, it doesn't seem to be doing anything at all. It says right here, apply power, BlueSCSI will now scan. During the target scan, the Pico stick LED will blink regularly. I saw no blinking at all. This can take some time to scan for targets, especially with older hard drives, blah, blah, blah. Yeah, I just realized I don't have the backfeed jumper installed. So let's get that installed. Let's power this back up. Okay, nothing's happening. On the Pico, that is, and that's understandable. Same thing, nothing. Perhaps there is some setting I need to make in the INI file, because I have some random stuff in there. So there's some system settings, delay. There's a debug setting, but I think it seems to be something to do with the logging on the SD card, so it's not that. You can optionally look for files in a subdirectory. Okay. Block size, right line, reinsert CD on inquiry, ROM settings, disable ROM, type, mag, raw. Yeah, it's not very clear. Yeah, I don't really see anything at all about the virtual serial port, actually. And it was information that I was given by Eric, who's the lead developer for the BlueSCSI side of the project. Let's take a look at the log file here on the SD card. So it's in initiator mode, will scan for images, and it looks like we are running the firmware that it says I need to use, which is this 11.16 version. Let's close that and take a look at this INI file. Maybe I just need to get this other random junk out of here. So I'm just gonna, yeah, maybe that's messing it up. So I'm just gonna change it to just be initiator mode 1. We'll save that. Let's pull this out. And I'm gonna unplug the BlueSCSI here, put in the SD card, and let's try again. Nope. Not doing anything. The only thing I'm thinking of is that this looks like it's a Wi-Fi version that's on here. And I'm wondering if the Wi-Fi version, I heard somewhere, or someone told me something, I think it was a PicoGus project. If you're using the Wi-Fi version, the LED that's on the BlueSCSI doesn't work. But I mean, of course we know it works. Because look, if I take this card out, then nothing's happening right now. Okay, did I break something here? Seems like it's not working at all now. Okay, so I seem to have caused some problems. I'm gonna stop the video now and do some troubleshooting. Okay, I'm back, and I think I've sort of come to a few conclusions. So, right now, let's zoom in. Here is the hard drive LED, and you can see that it is blinking. Now, looking at the BlueSCSI there, doesn't look like it's really doing anything, does it? You don't see any activity. I think what's happening here, and I asked Eric, who again is the maintainer of this project, the LED, it says in the docs, should be blinking on the Pi Pico to tell you, blinking rapidly, to tell you that it's actually imaging the hard drive. I think what's happening is this is the Wi-Fi version. I think the Wi-Fi version has a non-functional LED. And I know this because of talking to the Pico Gus team. That seems to be a limitation on the Wi-Fi version versus the non-Wi-Fi version. You can see this is the Wi-Fi one. It has a little metal shield right there. I've asked Eric if he could, Eric on the BlueSCSI project, if he could confirm that that is the case. Documentation doesn't mention anything about that, but I have a feeling that's what's going on because clearly the hard drive is imaging right now, and you know we don't have any indication of any activity on this at all. In addition, we didn't see the blinking when it was scanning for SCSI devices. I also can't get the virtual serial port working at all. It just doesn't come up. It never shows up ever. So right now, I obviously am powering it only from the Berg connector here, the power supply that's hooked up to the hard drive. I also removed the backfeed pin on here. There it is. The backfeed jumper is off this thing. Sorry, that's a little hard to see. So backfeed is on, you know, I have it just sitting on one pin, so that's removed. And it is working. This hard drive doesn't obviously need any kind of backfed termination power. Now, it might have been working fine with this on. I didn't notice the hard drive LED blinking. I was looking for activity on the Pi Pico. And since I can't get the serial port stuff working, I don't have any feedback from there either. So I'm just gonna let this sit and let it finish imaging this hard drive, which is just going and doing its own thing here. And then we'll take a look at what we see on the SD card once this process is done. And the only way I'm gonna know it's done is because the LED on the hard drive will turn off. Obviously that's not ideal because a lot of hard drives don't have LEDs on them. Like I don't think these do. And because it's not accessing the drive in any kind of random fashion, it's just sequentially imaging the drive, there's no real noise out of the hard drive. I just hear this drive spinning, but you don't really hear the heads accessing because you only hear that when they're randomly accessing the disk, and clearly it's just doing a sequential drive image right now. The docs do say 3 megabytes a second is something that you might see. So if it's a 30 meg hard drive, it might be pretty fast, although I don't think those hard drives actually could transfer 3 megs a second. It really depends on the type of drive. This hard drive, however big it is, it's been going for at least a few minutes now, and the light is still on. So anyways, jump cut time. Okay, so it finished, and I stuck the SD card into my computer here, and we have two files here, HD60 and HD61. And I have a feeling the 8 meg one has something to do with the fact that I unplugged the power while it was in the middle of imaging the first time. So that's probably it renaming the file and trying again. Now the funny thing is normally HD6 1 would indicate ID6 logical unit 1. It looks like this hard drive, I mean, this hard drive doesn't use logical units, so it would be HD60. So I guess this is using that logical unit number to like increment to the extra images. Let's take a look at the log file here. So yes, SCSI Initiator Mode, and here we go. It says Pico voltage. All right, SCSI ID6 drive total size 1013 megabytes, which is correct. I looked up the hard drive. It's a Connor CFP 1060S. So right there, 1062.3 is the capacity. And yeah, okay. Now it says HD00 imaged already exists using HD61. Clearly a little bug in the firmware. It should say 60 imaged already exists. So I'll open that as an issue. So there it goes. It's dumping the contents of the drive. It's going nearly 3 megs a second. That is pretty sweet. There are little like slowdowns here and there for whatever reason. It's the drive probably hiccuping. I don't really know how well this drive works. Oh, something's going on here. Read fails. Read from sector 1 million, whatever, incomplete. Failed to transfer 512 sector starting here. Retrying 1 of 5. And multiple failures, retrying sector by sector. So it switched to a different mode and goes really slowly. And I'm wondering if this aborted. It sure did. So I didn't turn this off until the LED wasn't flashing on the hard drive anymore. It had stopped. Clearly it didn't finish the dump And when we look at the file size, it's only 877. So that's a problem. And I'm wondering why the log file just kind of abruptly ended like that. That's kind of weird. Now, it could just well be this hard drive is just dying, but some more feedback would be pretty nice. And that's where like having that serial port would really come in handy. I guess what we can do is just try one of these other hard drives. This one here is an Apple hard drive, and I think it's a CP30175. It says here it's 160 megabytes. I obviously wrote in August it was working. So let's give this one a try and see if this behaves any differently. This drive does have the termination resistors installed, so that's a good thing. They're right here. We'll plug this in like so. We'll get the SD card. I should close this README file here. I'm going to move these two files here into the HD images and the slog file just so I can share this with the team to show them that something went wrong there and that didn't really work. And plug in the power. Okay, there was a green flash out of the Pi. Now it's just, I don't know. So this is again, where like, I don't know if it's doing anything. The hard drive's making weird noises though. So maybe it has died since the last time I used it. Okay, no. I can hear this. I can hear it actually working. It sounds like it's, yep, it's you know, the track-to-track head noise. This drive is making the normal sounds. It's an older drive, so it's going to be more noisy, and the head moves further when it moves from one track to another. It's definitely dumping the hard drive right now. Well, that was weird. So I didn't catch that on video, but what happened is it was the middle of reading this drive. The drive just spun down. I wasn't touching anything here. It spun down, it spun back up, and now I can hear it accessing again. So we'll have to look at the log file to see what's going on. And I'm chatting with Eric on Discord, and he says to turn on the debugging mode so that we can get more information out of what's going on exactly. Sounds like the initiator mode is a little bit of a work in progress here. So there's some stuff to work through a little bit. So I'll make sure to gather up all the debug logs and create some issues on the GitHub repo so the team can look into that stuff and hopefully get some of this fixed. Well, and the hard drive just shut down again. So I don't know what that means, and it hasn't spun back up. So I think I'm gonna pull this card out and let's take a look at the log file. All right, we have two files on here, HD00 and HD70. They are 166 megabytes, and this is a 160 meg hard drive. So what exactly happened? So HD7 isn't really possible because there are only 8 SCSI IDs, and the controller itself is always ID 7. So a drive can be configured from 0 to 6, and then 7, the 8th address, is always the controller. So why did it make one called HD70? I don't know. According to the log files here, there it is, total drive size, 162 megabytes. And it looks like it's imaging about 1 meg per second. Well, it sort of fluctuates around. Let's see if we can find out. Oh, here we go. So finished imaging drive. Okay, so we finished. Target 7 reports not ready. Running start stop unit. So it's seeing the hard drive as ID 7 and 0? So I guess it's normal that when it's done imaging the hard drive, it actually spins it down. So that's like a confirmation that it's done. Why would it image it twice? That's not really normal. So we have 2 good images though. Now we can take a look at the checksum here for both of the drive images just to confirm that we have 2 identical copies here. So there's the first one, and let's take a look at this one under checksums, and let's compare the 2 of these. Let's just take a moment because it's running right off an SD card. Yeah, okay, these are identical, like the SHA-1 here. So that's a bit weird. Okay, I guess I'll be submitting that to the team as well. So, also strange. But hey, it did work, and it was pretty quick about it, and yeah, that's really freaking awesome. So what we need to do here is we need to turn on the debug mode. So we're going to turn it on here. So we're going to get much more detailed logs to help the developers figure out what's going on with these drives. Alrighty, much time has passed, and I have finished going through all of the hard drives I have. I have a little stack right here. And well, the results were, shall we say, mixed. I ended up having quite a lot of issues getting these hard drives to image. I did have some successes. I'll go over the numbers in a second, But what I definitely needed to do is I had to use the ThinkPad here with the SCSI adapter in it just to validate that all the hard drives were working. And that's because I was running into so many issues where I would hook up the hard drive to the BlueSCSI in Initiator mode, and the firmware would act weird. Like it would, in the log file, say Initiator mode engaged, and then normally what you see when you have the debug on is you see it scanning for all the different SCSI IDs, and then when it finds an ID, it starts to image it, whatever. Well, it would just say SCSI Initiator mode engaged, and that was that. Never did anything more. A couple of these hard drives ended up doing exactly that. So it seemed like the hard drives were dead. So what I did, and I'll just switch here, is see this cable right here? This goes to this, which is going to the laptop here. And I would just unplug this, plug that in, and then on the laptop, I would insert the compact flash card that is the SCSI adapter, and then boop, the hard drive would appear. So I knew that the jumpers on the hard drive, the termination on the hard drive, all that stuff was correct. And the drive was functional because it would then just promptly show up in the OS on the laptop. And I was using Windows XP for this testing, and every single one of these hard drives showed up perfectly. Some of them are actually formatted for DOS, so those just worked, and the rest are like Macintosh or Amiga format, so it would show up and it wouldn't obviously be able to read the partition table and stuff like that. But I knew that the computer was able to read those drives, so there wasn't something wrong with the drive that would then result in the BlueSCSI having no ability to communicate with the drive at all. Now, what we're looking at right here is one of the issues. And actually, this hard drive, as you can see, these images are 4 gigabytes. So it's the biggest SCSI hard drive I have, and it took quite a long time to image. So I actually went to dinner and came back and it was done. But notice it's imaged it twice. We have HD00 and HD70. Now, I think there were 2 other hard drives that had this exact same problem, including, for instance, this 31 megabyte Seagate drive right here. And the one that I just imaged was this IBM drive. So this is a 4 gigabyte IBM drive. Now in the BlueSCSI INI, I turned on the debug logging. That way full logging is happening for every single one of these drives, and I saved each one of those logs. Because after you do an image, the next time you do another one, or you boot up the BlueSCSI, it erases the log file. So I took those log files off, put the drive name, put the symptom of what was going on, and this right here is the 4 gigabyte one that I just imaged, this IBM drive. Now I had to reformat the card as exFAT because the file was going to be more than 4 gigs, which of course is too big. But you can see what happens when you first power this on. So it normally says initialization complete, and then it starts showing more stuff. So here it is trying to talk to the hard drive. So selecting ID 0 and the initiator itself. So this is the BlueSCSI itself is ID 7, which is normal. And it's able to, well, I think it's able to talk to the hard drive. Yes, it is. So unit ready, request sent. So it's communicating with the drive. And what it does is it kind of goes through all this, that, and the other thing. And I think it's trying to like spin the drive up. I don't know, there's a bunch of stuff. In fact, actually, no, looking at this, it didn't actually start imaging the drive. Now, it could be the drive was spinning up and it wasn't ready yet. So the BlueSCSI goes to look at the rest of the SCSI ID. So here it is talking to SCSI ID 1, and it's not responding. 2, 3, 4, 5, 6. Now 7 doesn't really make sense. So it is technically possible to set a hard drive to ID 7. You would install all 3 of the jumpers on like this SCSI ID selection. So what the BlueSCSI does is it sets itself to ID 0, and then it tries to talk to the drive. Well, for whatever reason, in the case of this hard drive and 2 of the other ones, the hard drives, they respond to ID 7. So they respond to whatever they're set to, and also ID 7. I have no idea why this is. I don't know why the BlueSCSI is configured to even look at ID 7 and it changes its own ID, but it does. But out of all these hard drives, how many do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did 10 hard drives. 3 of them do this, where they respond back on ID 7. So what happens is it begins to dump the data. So SCSI ID 7, here's the capacity, 4,334 megabytes, and it proceeds to image the drive. And HD 70, there it is. And there's a zillion debug log entries of that happening. Well, somewhere in here, what happens is it finishes dumping the entire contents of ID 7. And what the BlueSCSI does at that point is it starts searching for other hard drives. And it will just do that forever. So I think the whole idea is you could unplug the hard drive you're imaging and plug a different one in, because you can kind of hot swap SCSI. I don't know if you're supposed to or not, but you can. You can hot swap SCSI and it will pick up on that new ID and then start to image it. Well, in the case of this hard drive, you can see here, that it imaged it at ID 7, which I don't know why the drive responds to ID 7, but it does. And then it images it again at ID 0. So we ended up with 2 4 gig files. Now the other 2 drives that it did this on, so the 3 total, this one and the 2 others, it created a proper image. So we got a good dump of all 3 of those drives. But this behavior to me seems a bit weird. And the problem is it takes twice as long, which is a really long time on this large drive. So, well, I'm not the person who came up with the software here, and I don't want to like make any criticisms that are unjust. Maybe there's a good reason for this behavior, but it seems like a bit of a bug because it ends up making multiple images. And I mentioned this behavior to Eric over Discord, and Eric thought that that was weird. So I think maybe it's unanticipated or unintended, the consequences here. Either way, if the firmware was just altered to not look at ID 7, then that would fix the problem on 3 of these drives, and I would have had 5 good rips of hard drives. So out of the 10, 5 worked properly. Now, if we look in this directory here, I've been saving the log files. So drives that work, this Fujitsu drive worked normally. It just created an image, there was no issues, it just worked perfectly, and it didn't create 2 different images. Now, I thought originally that I had 2 good images made, plus 3 hard drives, including this one that I just did, that created the 0 and the 7, so that would have been 5 total. But no, I only had 1 that worked flawlessly, that Fujitsu drive, and then 3 that did the 0 and 7. So I got 4 good dumps out of these 10 hard drives. So if we go to drives with issues, all of these had one problem or another. Now let's start this first one here, and I'll talk through the various issues that I saw. So this particular one here, the drive is ID 0. Oh, okay, this is one where the drive is ID 0, but it saw ID 0 and 7, so it created 2 dumps. So other than that, worked totally fine. Obviously, Windows XP and the Adaptive SCSI controller just shows the drive one time. It doesn't see 2 hard drives. So that drive there, that was a Connor drive that was behaving like that. Now, the next drive here, this Connor hard drive is actually 1 gigabyte hard drive, 1016 megabytes. But what happens is it only actually dumps 877 megabytes. And if you kind of scroll through all this gobbledygook here, eventually it has an error. Now, unfortunately, it's a little easier to read these logs when you don't have the debugging turned on, because all this debug stuff isn't there. But here it is. It's pulling down the sector out of like the total number of sectors there. It was grabbing 100 or 1.75 million or whatever it was. Okay, well, somewhere in here, there's like a bad sector. It has like a read error. And what happens is the BlueSCSI switches over to a sector by sector mode. Well, it eventually just sort of gives up. It gets to this point here where, see, it read, there's a sector 866, 867, and that's that. It just stops. It has some retries that it's showing, and it usually gets to like retry 1, and I think retry 2, and then it stops. So anyways, there's obviously some kind of a firmware thing going on, because I saw this exact behavior on 2 drives. And it must be that those 2 drives just have bad sectors on them, and they weren't mapped out or whatever, like in a format. So yeah, these drives are sitting around. I don't use these drives, so it's possible they're failing just sitting around. So that's one of the problems. So I could not get a successful dump off this hard drive, this Connor or whatever, and one of the other ones. So we'll get to that in a second. This hard drive here, I had it set for ID 1, and when I first connected it, what happened is it initialized everything and it started scanning for SCSI IDs. Well, you can see here that it tried to talk to 0 and the drive was set to ID 1. Well, 0 didn't respond. And then it went on to talk to ID 1, but that's it. Like the firmware crashes or whatever happens, there are no longer any entries in here at all. Now what happened is I switched the hard drive from ID 1 to ID 0. And when I did that, this is what you get. So it looks like, similar to that other one, it goes to talk to ID 0. It doesn't even create anything in the logs here. And then what happens is it just fails. And it kind of hangs up, and that's that. And you can leave this here for like 10 minutes and nothing ever happens. So I just thought it was kind of interesting that I included logs for 1 and 0, because the 1 had that one thing where it was trying to talk to 0 and it couldn't. So it just said, oh, not found. We moved on to 1, but the log didn't even show anything. And then, of course, it just froze up and stopped working. This drive here, M Systems, is a 512 megabyte solid state drive that is SCSI, if you can believe it. It's in the stack right here. And let's see what happens with this one. This one was set to ID 0, and it did exactly that. See, I said ID 0 at the top here, and Same exact behavior as that other drive, that previous one, where the BlueSCSI firmware just sort of crashes or whatever happens, doesn't create any log entries, and then it just totally gives up. So it is funny though, like, you know, different Connor drives behave differently. Like we had one Connor drive that worked, but it created the 0 and the 7. Another one that went through most of the hard drive and then it crashed or, you know, stopped pulling data down. And then this one here, this CP3100 that just crapped out entirely. Same with this MSCSI thing. Quantum Fireball. Drive goes sector to sector and then just stops. Okay, so it's the same exact problem as that other one. So basically it's maybe a bad sector on there. So somewhere in here you have a read error. And when you get to the bottom here, what it does is, okay, this one actually died in a different spot. So you can see here, there's a read error of some kind. Retry 1 of 5, it's going to sector by sector mode, but it never even gets into that mode. The other drive, the 877 meg, well, the 1 gigabyte drive, it goes into sector by sector mode and then it breaks after it does that for a while. This one just breaks going right into that mode. We have another quantum drive, an LPS drive here. Confirm this drive works with Windows XP. I think this one, it tries to talk to the hard drive. So the hard drive was ID 0 and you can see it talking to it like it's trying to start, stop, whatever, not ready. And it looks like it has like a failed command and it does some more stuff here. And anyways, start, stop, fail, sense key, whatever, and it seems to try to go on to SCSI ID 1 and then the firmware crashes on the BlueSCSI. So it just stops at that point and never does anything. The drive might have been spinning up, or I don't know what the drive was doing at the time, but I think when it did this kind of stuff, I actually tried multiple times. But like I said, if I just moved the drive over to plugged into the laptop, the drive was actually working perfectly. And then we have this Seagate drive here, which is a very old Seagate drive. This one was this one right here on the top. This is like a 30 meg hard drive. This one actually worked fine, except it had the same problem with the 0 and the 7. So that was the only issue there. And another Seagate drive, I think a 2 gig drive. And this one does the thing where it was set to ID 0 and it didn't initialize it at all. So I think we had 3 of those where the firmware on the BlueSCSI seems to kind of crash when it tries to talk to the drive. And these are across different brands. And then we had 3 drives that were doing the 0 and the 7. And then we had 2 drives that were doing the, like it would go sector to sector mode or would have a read error and then that would crash. And I think that was all of them. So what I need to do here is I just need to copy this log file over here, which is this IBM drive here. And we just need to edit this file and say it was set to ID 0. So yeah, there we go. ID 0 and drive is seen as both ID 0 and 7, so it creates 2 files. Otherwise, it works. All right, we'll just save that. So this kind of shows that this particular feature is definitely a work in progress. And incidentally, this feature is on the BlueSCSI version 2. It's also on the ZuluSCSI, so the newer ZuluSCSI devices that run the Raspberry Pi Pico or the RP2040 microcontroller. And that's because those 2 things share the firmware. In fact, I think the BlueSCSI version 2 firmware is ported over from the ZuluSCSI one. And I noticed there's, looking at the ZuluSCSI GitHub repo, like there's stuff that's being backported as well. Like, anyways, there's a lot of similar functionality between the 2, and I have a feeling any of the issues that exist with the Initiator mode on the BlueSCSI version 2 are also on the ZuluSCSI. So this feature at this point, like right now, as of the making of this video, using the firmware that came out in November of 2023, definitely work in progress. And I mean, the fact is, I was able to get images off of what, 4 of the hard drives here. And there were 2 additional drives that it did create an image, but then there was those bad sectors. So if those drives didn't have bad sectors, I might have actually had 6 hard drives that were imaging properly and only 4 that were really stuck in that thing where it either tried to talk to the drive and it would fail, or the drive wouldn't even respond at all, or whatever. The firmware would crash without any response at all. All right, so that brings us to these removable devices. I have no idea if these are going to work at all, so why don't we try the zip drive first, and then we'll try this SideQuest drive last. All right, this is the setup for testing. So we have the power supply here. This is to power up the BlueSCSI itself. It goes through this bird connector. We have a ribbon cable that goes to this 50-pin connector, which then goes into the zip drive connected to the SCSI input jack on the back. The zip drive has internal termination, which you can enable or disable. There's a switch on the back. And the last thing I need to do is connect up the cable here for the zip drive. Incidentally, I have a lot of zip drives. And if you have a zip drive that is misbehaving, as in You plug it in, it sort of works. You put a disc in there and it's very, very misbehavey. Is that a word, misbehavey? It can be the power supply. I've had multiple of these, and the reason why this is a different power supply in here, it's like a D-Link router power supply. It's just a 5-volt power supply. The reason why that's on there is because the one I had with this drive, or I don't know, whatever, one of the drives, it seemed to work, but it would never load disk correctly. It would just make all this clicking noises or whatever. I swapped out the power supply, and then that was that. It worked perfectly. For testing, we're going to use this disk here. It's DOS stuff, so that means it's formatted for MS-DOS. So that means once the image is created, we'll be able to read that off of the card here. And I can use a program on Windows to actually look at the contents of it, just to make sure the read is good. Because to be honest, I have not tested any of the images that have been created with this to see if they're valid versus what's on the actual disk. Let's turn this on, see what happens here. So far nothing's happening. So the activity light should just start blinking. Usually it takes a couple seconds for it to figure out what's going on. And that's not the case. It doesn't seem to be working here. Now what I can do is pull the power on switch off of this that kind of like powers it all down, including the Raspberry Pi, and then we can turn it back on. Okay. I've seen this issue before. When I turn this on, we should be seeing a green flash, and now it should be blinking because the SD card is not installed, and it's not doing that. But if I turn that off and we take the zip drive and we power off the zip drive, watch what happens when I turn this on. I bet you the light's gonna blink now. See? That is normal initialization. So if I put this in, it actually tries scanning the SCSI bus and everything. I don't know what's actually going on here. I saw this particular issue depending on how I was like backfeeding power and stuff like that when I had those other hard drives connected. It ended up not being an issue with the hard drive. I powered them all off the same power supply as the BlueSCSI. So I was using this splitter cable here. If I was using that, it worked every time. But if I was like trying to run the BlueSCSI off like USB, and then I was running the hard drive off the power supply, I'd get into the situation where it just wasn't initializing. See? Normal. But if I turn on the zip drive, even though it's not backfeeding power, look, when we turn this on, okay. Well, now it's working. Let's put the disk in. Let's put this in. Let's turn this on. No, it's not initializing. It has to do with whether the disk is in the drive or not. I don't really get that. But look, see, nothing. No blinky blinky. Take this out. Reset the power. And now it's not doing it. I pull the power out of the zip drive, so it's off. And we power cycle this. Now it's blinking. And when it's in that state where the light's not even blinking, this Raspberry Pi Pico is dead. I mean, it's not physically dead, but I can't flash firmware to it. I can't talk to it. It's as if it's not booting up at all. I don't get what's going on here, but there's something electrically happening that is not compatible with this drive. And since well, I guess I could power it off the power supply, couldn't I? But I think it has something to do with like voltage potential between this, and it's unhappy. So I don't really understand what's going on here. And this sort of means that we can't do any testing with the zip drive because I can't get this thing to initialize while the zip drive is powered on. So I think we'll just have to move on to the SciQuest drive, which at least is going to be powered off the same power supply as the BlueSCSI. I'll be able to use that splitter cable. And just in case you were wondering, the SCSI termination was turned on the entire time on the zip drive, and it needs to be. You have to terminate the device on the end and at the start of the chain, and this is the end device, obviously. Okay, so for the SciQuest drive, termination resistors are installed. That's what I was just checking for. Let's get this SCSI cable plugged in. With the BlueSCSI, I'm going to set the power on jumper back to on, and let's power this on and see if we get the normal initialization. Yep, normal initialization. Excellent. So we'll just turn this off. We have the card in there, and hopefully this is a working disk here. It says tester on it. So with everything powered up again, that thing should be sitting there scanning for SCSI devices. Let's get this thing in there. Okay. All right, so it's not even spinning up. Light's blinking, but that's it. Let's unplug the SCSI cable here, and let's see if that makes a difference. No. So this drive has failed. Like since I last used it. Really? All right, I have the big guns out, 200 or 300 watt power supply or whatever this is, plugged into the SideQuest drive. Let's turn this on. I have a power switch over here on the cable. Yep, that's spun up. So I guess this is a power hog, and these little power supplies here aren't good enough. Interesting. All right, BlueSCSI is connected to the power supply. The SCSI cable is reconnected. We'll power this on again. Okay, that initialized, excellent. And I'm gonna move this lever over, which should spin up the disc. It is, it's spinning up. Sounds normal, the light turned green, but we're not seeing anything happening on here. I figure, oh, no, the light's orange now. Oh, I think it's doing it. I think it's doing it. It's doing something, that's for sure. Yes, I think it's working, actually. So the funny thing is, while the activity light doesn't really work correctly, it does blink ever so slightly, this one right here. Very faintly. So I think it's doing it. It's imaging this funky SideQuest drive. So that is fascinating. That kind of leads me to believe that it would work with the SCSI zip drive as well. I mean, the thing about zip drives are really easy to find IDE versions of it, and then you can connect that up to a modern computer with a USB adapter and then image these disks. So it's not as critical, but I don't think they ever made IDE versions of these SideQuest drives. Plus there's all the other SideQuest drives and Jazz drives and those types of things. I think those are always only SCSI. So the fact is, it is working with this removable drive, which kind of shows that it might work with this and other stuff too. Well, I think what I'm gonna do for the zip drive is I think I'm gonna power it up off of this ATX power supply using this, hey, the disk stopped spinning. So that's cool, that means it finished. So that's actually what this thing does, is after it's done imaging a drive, it sends the stop command to it. And most of the drives, well, the ones that worked, even the ones that had ID 0 and 7, did eventually just stop the drive, and then it was just sitting there waiting for me to, you know, power it off. This thing is still trying to find other SCSI devices. Let's pop the card out, take a look at it on the computer. All right, here's what we have. So I didn't delete the old images. It's obviously set for ID 2. That's cool. The good thing about Initiator Mode, by the way, is it doesn't overwrite any files that are there. So if you have a second drive with the same ID, it will create it, you know, called ID 2, 1, and 2, 2, 2, 2, 3, 2, 4, etc., etc. So looking at the log file, looking for the drive, it looks like it found the drive. Maybe the drive wasn't ready. So like the drive was in the middle of spinning up. So it sits there, does more searching, test unit ready. This is all very normal activity, what's happening here. And there it is. The drive responded and said, hey, I'm ready to go. I'm 128 megabytes. I guess that's the formatted capacity of these disks. Pre-allocating the image file, so it writes that to the SD card, and then it starts going from there. And if we go to the end here, read successful 262.144 of 262.144, 2 megabytes per second. And then it sends this stop unit, so that turns off the disk or stops the disk spinning, and there we go. It just starts looking for the other stuff. So that is an example of how it should work when everything is lined up and the firmware on the BlueSCSI is liking the drive it's talking to, and it all works. So yeah, that's pretty cool. That was a success right there. So I'm just gonna move this log file for the Easy Flyer into drives that work. So now we have 2 things that worked perfectly. All right, so since that was a success, and I think the problem we were having with the zip drive before was the fact we were using 2 power supplies, I'm going to use this wire here to clip onto this Molex connector to get the 5 volts right from the ATX power supply and power that up at the same time. Make sure these nails don't fall out here. And if I turn on the power supply, zip drive is on, it's blinking there, which sounds normal. So let's put a disk in here. I don't have the SD card in the BlueSCSI, so let's put this in. See, there we go. Okay, it had 1 blink, which means it's configuring. So yeah, that was the problem. It was not happy and not initializing because the zip drive was powered up with a separate power supply than this. So just know that that seems to be an issue, at least with the revision here of this board. I don't know if fixing the jumpers or changing jumpers would have fixed that issue. And look, it's freaking reading the disk. So it does work with zip drives. Look at that. Freaking awesome. Let's just see what happens when it's done. You know what would be really cool is the firmware here could be fixed, that when it was done reading a removable disk like this, that it ejected the disk. So it didn't just stop the disk, it actually ejected. That'd be pretty sweet, little feature add. All right, I'll just let this thing finish. All right, there we go. Oh, it did eject. That's so cool. It stopped it and ejected the disk. I love it. All right, let's test, let's see what's on the card, that is. All right, there it is, 98 megabytes. That's the formatted capacity of the zip disk. We'll copy both of these files off. And if I rename the file to IMG, then that should allow us to open it in WinImage. There it is. There's the contents of that disk. It freaking works. And in Notepad++, we're getting these errors on the SDIO interface, SD card or whatever. I don't know, that might have been because the card wasn't installed when I powered it up. Either way, it starts looking for the SCSI device. It finds this one on ID 6, and we keep going through, and there it is. Drive total size, 96 megabytes. It'd be cool if the log file actually showed like the vendor information from the SCSI device. Doesn't seem to show that. Anyhow, it seems to work. And if we scroll to the bottom, there it is, read successful. All the sectors, it read at 744K per second. Not bad for a floppy disk, which is what a zip disk is. It's just a high density floppy disk basically. And it seems like on the zip drive, when it sends the start stop unit, that actually ejects the disk. And then the BlueSCSI went on to read other things. So there we have it. That was my exploration and my testing of the SCSI Initiator Mode on the BlueSCSI version 2, using firmware, of course, from the 16th of November, 2023. Obviously, one of the caveats that we were just looking at with the zip drive, and I noticed it with some of the hard drives too, is yeah, you have to power the entire board here off of the same power supply that of the device you're trying to copy off of. If you do them separately, it gets into that state where the Pi Pico doesn't initialize. Now, I have to say, even though I've had a lot of issues with this particular function on the BlueSCSI right now, that doesn't take away from how cool I think this device is. Obviously, the SCSI hard drive and the SCSI device emulation of this is its main use case, and that stuff, well, as far as I'm aware, because I've only used it a little bit, works really well. So you're not going to really run into any of these types of issues with that, because that's a really well-tested, well-bug-checked part of the functionality of this card. Initiator mode, obviously, this is a new feature for this and hasn't had a lot of testing yet. So that's why it's strictly a work in progress. And I don't want to take away from like any of the awesomeness that this thing has. And in the testing here, I was able to get some good images off various devices. And for instance, I'm really lucky because I have this laptop here, which allows me to very quickly and easily image SCSI devices because it has the adaptive SCSI card, and it's, you know, Windows XP and there's Linux. Most people aren't going to have that. And if you have an old hard drive on an old Macintosh that, you know, still works, still boots, but you want to create an image from it, this right now is going to be your best bet at doing it in a very inexpensive way. And as the firmware matures, it should be a very reliable way of doing it as well. So my experiences with this functionality is very much a point in time. And as this firmware matures on here and bug fixes go in, potentially all of these issues are going to go away. Of course, I'm going to be sending all the logs and all the information I've gathered from my experience using the initiator mode here over to Eric. And hopefully that will result in some firmware fixes that can improve the compatibility where maybe only 3 of these drives won't work and the rest are going to work perfectly. Because I think the only ones that might be the really difficult one to fix, it's not this drive, but the ones that when I connected it up, it didn't log anything. Like it would just initialize and sort of die at that point. That's going to be harder to troubleshoot without using a SCSI analyzer and really looking at what the communication is going on. But the rest of that stuff, like the 07 ID things, that should be fixable. The bad sector retry stuff where it kind of dies, that's probably fixable as well. And well, and now we know to power this up from the same power supply as the device under test, under capture. That solves the issue with the zip drive. And the SideQuest drive just worked. But anyhow, yeah. So there we go. That's the BlueSCSI. I really recommend this product. It's a really cool thing. And the ZuluSCSI as well, which is also open source now, is similarly good. They seem to have the same features. I'm not sure why you'd want to pick one over the other, but like I said, the firmwares, there seems to be a lot of sharing going on with the firmware on both those devices. So it doesn't look like you can really go wrong with either of them. And this is specifically talking about the ones that use the RP2040 microcontroller. The older versions of both of these, I don't think use the same firmware. So that means a lot of these features aren't going to be available and you really have to use these newer ones. So anyhow, thanks again, Joe, for sending this into the basement. Plus, Joe sent me another one, which is sitting, oh, right here. It's this little plug-in version that plugs into the back of your like compact Macintosh, Mac Plus or whatever like that. That way you don't even have to open it up. And you can just plug this in, boot right up. Perfect for testing. It's freaking amazing for testing, to be honest. What a cool product. Thank you very much, Joe, for sending it. Thank you, BlueSCSI team, for working on this. And hopefully you found this troubleshooting process interesting. I think this is all par for the course with you know, open source projects. There's not a huge team of people. This is not Apple or Google with like a massive team working on it. This is really just a small, tiny community working on this product. And obviously bugs and things are just there because there's only so much testing one person can do. So hopefully the testing I've done here can at least result in some useful information that can improve the firmware for everyone. So anyways, that's gonna be that for this video. Thanks to my patrons. Names are scrolling up the side of the screen. Subscribe if you haven't already. This is the second channel. It really helps me out if you do subscribe. And I think that's gonna be that. Stay healthy, stay safe. I'll see you next time. Bye-bye.